Hello friends, welcome to HP Mathematics Academy. In the last lecture, we were discussing the important results on Serret and Frenet formula. Okay, so in this particular lecture, we will discuss about the problems on the Serret and Frenet formula. Okay, so before proceeding further, let us revise those important results. Let's revise those results. Okay, so we have the important results as unit tangent vector is given by dr upon ds. Secondly, we have double differentiation of r with respect to s is given by kappa n. Dt upon ds is kappa n. This is as per the first result of the Serret and Frenet formula. Secondly, we have ds upon dt. ds upon dt is obviously a scalar quantity. This is equal to modulus of dr upon dt. And notations we have discussed. Single prime. R prime is differentiation with respect to s, and dot r dot is differentiation with respect to we have discussed. Secondly, what we have discussed is that if the curve is in terms of s, the curve is in terms of s, curve is in the terms of, then we have value of kappa as kappa is equal to cross product of dr upon ds cross d2r upon ds. Tau is given scalar triple product of dr upon ds r upon q r upon s cube dr upon d r upon square का modulus. This is cross product of dr upon ds and d2r upon ds square का whole square. Okay. And if the curve is in terms of t, curve is a function of t, then we have kappa is equal to dr upon ds cross d2 dr upon dt dr upon dt cross d2r upon dt modulus upon dr upon dt. Tau is given by tau is equal to scalar triple product of dr upon dt d2r upon dt dqr upon dt upon cross product of dr upon dt r upon. If the curve is a function of s, then the kappa is given by this particular expression, tau is given by this particular, this one is the scalar triple product. Similarly, if curve is in terms of t, curve is a function of t, then we have kappa is given by this particular expression, tau is given by this particular. This we can write as, this we can also write as, because let us take r as, r is a function of, just present r in terms of x, y, z. So x I cap plus y j cap plus z cap. We have the single differentiation r dot, that is differentiation. This is equal to dr upon dt. dr upon dt. This is equal to x dot I cap plus y dot j cap plus z dot k. Double differentiation d2r upon dt is equal to r double dot. This is equal to x double dot I cap plus y double dot j cap plus z double dot k. Similarly, d cube r upon dt cube equal to r triple dot equal to x triple dot I cap plus y triple dot j cap plus z triple dot k. Okay, so the scalar triple product we can write as scalar triple product, that is dr upon dt d2r upon dt d cube r upon scalar triple. This is equal to the coefficient of first vector. Let us write down the coefficient of first vector. Coefficient of first vector is x dot, y dot and z dot. Let us write down here x dot is dot, y dot and z dot. Now we have d2r upon dt. Coefficients of second vector x double dot, y double dot, z double, x double dot, y double dot, z double, d cube r upon dt cube. Coefficient of third vector x triple dot, y triple dot and z triple dot, y triple dot and z. This we can write in this form also. Let us place the scalar triple product here. We have We can represent this like this on. Let's remove this. We have this as x dot y dot z dot x double dot y double dot z double triple dot y triple dot z triple determinant. This is the expression for torsion, the expression for curvature. Okay, there is a correction actually. So in the last lecture, I have written here prime. So this is not prime because we are taking the differentiation with respect to time. So it will be dot. Here we have dot, not prime. Prime is in the case of differentiation with respect to s. Now let us start discussing the problems. Now let us discuss. So in the first question, for the space curve given by, let us discuss one by one. So in the first question, we have the space curve x is equal to a cos t, y is equal to a sin t, z is equal to bt. So that a is equal to a upon a square plus b square and z tau is equal to b upon a square plus. Let's discuss this. We have this as the question. It is given by the curve is given as, we have this, we have the curve as x is equal to a cos t. We have the radius, we have the vector r. We have this, have the vector r as, r vector is given a cos t I cap plus a sin j cap plus b k. You have to find the kappa and tau. Okay, so here the curve is in terms of t. Here the curve is in terms of t. We will apply this particular. We have kappa is equal to dr upon dt cross d2r upon dt square upon dr upon dt ka whole cube. Tau is given by this particular. We have the kappa is equal to dr upon dt cross r upon mod upon dr upon dt का mod का whole the expression. Let us find dr upon dt. Have dr upon dt. Let us write down here. We have kappa is equal to this particular expression. Let us find dr upon dt. Dr upon dt is equal to r dot equal to minus a sin t I cap plus a cos t j cap plus b d2r upon dt square is equal to r double dot equal to minus cos t I cap minus a sin t plus 0 k. We have d2r upon dt cube upon d2 d cube r upon dt cube triple differentiation r triple dot equal to a sin t cos t cap plus. So we have dr upon dt cross dr upon dt cross d2r upon equal to cross product is, we have this as I j and k. We have the coefficients of first vector. So first vector is minus a cos t. Coefficient of second vector, that is d2r upon dt is a cos t a sin t equal to I times of I cap. This is minus k minus ab sin plus j cap cos t j times of k cap a square. This is a square sin square t plus minus minus plus, this is equal to dr upon dt cross d2r upon, let us take modulus. We have dr upon dt cross d2r upon r equal to a square b sin square a square b square cos square plus e power 4 the root. This is equal to a square b square we can take out. And this is sin square t plus cos square 1 square b plus the root. A square b square plus the root. A times of square plus the value of dr upon dt cross d2r upon. Okay. Now let us find dr upon dt ka mod. Dr upon dt, modulus of dr upon dt is a square sin plus square cos square of b the root of. We have the value of kappa is equal to dr upon dt cross r upon mod dr upon dt equal to the value is dr upon dt cross modulus of this is a times of square plus dr upon dt का whole cube a square plus square under root का equal to a upon a square plus a upon a square plus the value of. Let us find the value of tau. How we can find this? We have this particular, the modulus, this value is given as a times of under a square plus a times of. Now let us find the torsion. We have the value of torsion as scalar triple product dr upon dt r upon dt dq r upon dt upon dr upon dt r upon square come a whole. Value of this is dr upon dt cross d2 r upon dt square is a times of root under a square plus this value we are having. So let us find the scalar triple product. Scalar triple product, how we can find this? This particular expression. Have dr upon dt d2r upon dt dqr upon scalar triple product. This we can present as, let us write down the coefficient of first vector, that is dr upon dt. Coefficient of first vector is this dr upon dt minus a sin t cos t. Coefficient of second vector, that is d2r upon dt minus cos t. Coefficient of third vector, this is a sin t cos t. Let us find the value of actually determinant. Scalar triple product we are taking equal to b times of cos multiplied times of square cos square. The value of scalar triple product r upon dt d2 r upon dt r upon. Let us place the value here equal to times of whole square of this square of Let's solve this. Equal to tau is equal to square upon whole square. Gets cancelled. This is equal to b times of b upon. We have the value of k as this. We have to prove. We have to prove k is equal to a upon a square plus b square. Tau is equal to b upon a square plus. We have the value of tau as b upon a square plus b. Value of kappa as a upon square plus. Now let us discuss question number 2. Let's discuss question number 2. In the question number 2, we have to prove that the radius of curvature is reversal of curvature 1 upon k with parametric equation x is equal to function of x is a function of s, y is a function, z is a function of, curve is a function of s. So the value of radius of curvature is given by this particular expression. Let's show this. Have have the radius vector as this I cap plus z k. Have the unit tangent vector. Unit tangent vector t is equal to dr upon ds. Let us find dr upon ds. Dr upon ds is equal to x upon plus y upon ds j z upon ds. Let us find d2r upon ds square equal to d2x upon ds square I cap plus d2x upon ds square j cap plus d2z upon ds square k. Okay. We have the value of d2r upon ds square is given by kappa n. Kappa n is equal to d2x upon ds square I cap plus d2x upon ds square j plus d2z upon ds square. Let's take modulus both. We have modulus of kappa n and modulus of this. We have the modulus of kappa is a scalar quantity. Okay, n is a unit vector. So modulus of unit vector is 1. So kappa is equal to 2x upon square whole square d2x upon y 2y upon s squared upon s square का whole का under root. Let us take 1 upon k. 1 upon k. 1 upon k is radius of curve equal to reversal of this 1 upon square whole square d2y upon z upon this we can write as d2 y upon z upon minus 1 equal to we have to. Let us discuss question number 3. What is given in question number 3? dr upon ds dot d2r upon ds square cross d cube r upon ds cube is equal to tau upon rho square. Let's show this. Okay, so in the question number 3, we have to show that dr upon ds dot r upon cos r upon ds cube equal to tau upon. How we can solve this? We have the value of unit tangent vector as dr upon ds. We have dr upon ds equal to unit tangent vector. We have d2r upon ds square is equal to kappa n. dt upon ds is equal to kappa n, and dt upon ds is d2r upon. We have dr upon ds cube, d upon ds of d2r upon ds square, r upon equal to d upon ds of kappa n equal to k times of n upon d dk upon ds into dn upon ds we can write as dn upon ds is tau b minus have qr upon d equal to k times of tau b minus 40 plus dk upon ds times of equal to tau kb minus k square t dk upon ds of n cube r upon. Let's place here. We have dr upon ds dot d2r upon square cos d2r upon equal to dr upon ds is d dot d2r upon ds square is equal to kappa n. Cross product, cross of d cube r upon ds. How k upon can write as this dot tau k square cross b minus k cube n cross times of dk upon cross n. The cross product of same vector is 0. Is 0. We have from right hand thumb rule. This is unit tangent vector. This is normal, principal normal. We have right hand thumb rule. N cross b we have to find. N cross b is equal to t dot tau k square minus k cube n cross t. We have t cross n, t clockwise. T cross n equal to b. N cross t equal to minus b. Minus b. This is minus plus. So this is equal to tau k square t dot t plus dot b. T and b are perpendicular to each other. So dot product is 0. We have dot product of same unit vector is 1. So t is a unit vector. T is also unit. T dot t is equal to 1. Dot product of unit vector is 1 equal to tau k square. K is equal to 1 upon rho. K is equal to 1 upon rho. Tau upon is the value of r upon dot r upon cos r upon. This we have to tau upon. Let us discuss question number 4. Let us discuss In the question number 4, we have to find a unit tangent vector to any point on the curve x is equal to a cos omega t, y is equal to a sin omega t, and z is equal to bt, where a, b, and w are a, b, and omega are constants. Solve this. So we have the radius vector. We have solution. Fourth part. We have value of r vector. R vector by a cos omega sin t j cap plus bt k cap. We have to find the unit tangent vector. So unit tangent vector is given by dr upon ds. Just find this, we can write as dr upon dt upon ds upon ds upon dt is modulus of dr upon. This we have already studied. The tangent vector ds upon dt is equal to dr upon dt mod. So just find dr upon dt. Dr upon minus का sin का cos omega pk, the value of dr upon dt. Dr upon dt a mod square omega square omega square cos square have p square square a square. So we have a square omega square sin square omega. We are taking modulus of this dr upon plus a square omega square cos square omega under root equal to a square omega square we can take out, and sin square omega t plus cos square omega t 1. A square omega square is the value of dr upon equal to ds upon third result. Let us place the value here. So we have t is equal to dr upon dt. Dr upon dt. Dr upon dt. S upon dt. A square omega. The expression for the unit tangent. Okay. Now let us discuss question number 5. In the question number 5, we have to find for the space curve x is equal to t, y is equal to t square, z is equal to 2 upon 3 t cube, and the values of k and tau, that is curvature and torsion at t is equal to. Let us solve this. Okay, so in fifth one, have we have the space curve x is given by x is equal to t, y is equal to t square, z is equal to 2 upon 3 t cube. We have r vector as I cap plus square j cap plus upon 3. We have the value of dr upon dt I cap t j cap plus 2t square k cap d2 r upon dt given by 0 plus j cap t k d2 r upon d cube r upon dt equal to 0 I cap plus 0 j cap plus 4k. Let us find the value of kappa. Kappa is equal to dr upon dt cos d2 r upon dr upon dt. Let us find the value of k. For finding the value of k, let us take the cross product. Dr upon dt cross d2r upon equal to equal to matrix form of ij dr upon dt. One coefficient of first vector, that is dr upon dt. 1, 2t and 2t. Coefficient of d2r upon dt is this one. 0, 2 equal to I times 8t square, 8t square minus 4t plus j cap. 0, this is plus k cap. 2 equal to 4t square I value of dr upon r upon. Let us take the modulus here. Let us take mod equal to 16t plus. Let us take 4 common. 4 times of 4t square plus of square plus 1 times of square plus value of this equal to this value is times of 2t square plus value is times of. Now let us find dr upon dt का mod का whole cube. Dr upon dt equal to modulus of this 1 plus this is equal to the root t square plus 1 dr upon dt mod का square plus 1 plus place here we have kappa is equal to times of 2 square plus equal to 2 times of square plus kappa at t is equal to 1 plus place here times of this is plus 1 upon. Let us find the value of torsion, that is tau. We have the value of tau as this one. Tau is equal to scalar triple product of dr upon dt, d2r upon dt square and d cube r upon dt cube. Dr upon dt cross d2r upon dt. This we have already calculated. Dr upon dt cross d2r upon dt. Given by. Let us find the scalar triple product. Scalar triple product dr upon r upon r upon equal to determinant of. Let us write down the coefficients of dr upon dt. Coefficient of dr upon dt 1 2 t d2r upon dt 0 2 d cube r upon dt cube. So 0 will be equal to 1 times of 1 cross 2. We have the value of tau as 8 upon. Let us write down complete equal to your scalar triple product dr upon dt r upon dt dq r upon dr upon dt cross d2 r upon per mod का, this is equal to, the value of this one is scalar triple product 8 upon, this is dr upon dt cross d2 r upon dt square का t square plus equal to 8 upon 4 times of t square plus 1 gets cancelled to 2 equal to 2 upon t square plus, when tau is tau, the value of tau when t is equal to 1, t is equal to 1, let us place t is equal to 1, 2 upon 1, so 2 plus 1 is 3 का square, value of kappa and tau are same, that is equal to 2 upon 9 when equal to, okay. We have discussed up to question number 5, so we will discuss further questions in next particular lecture. Thank you.